We're going to do a quick recap of covalent versus ionic and being able to practice being able to identify if it's covalent or if it's ionic using formulas or names. So first thing to recap ionic bonds are between it's between a metal and a nonmetal typically, but always between a cation and an anion. When I say metal and nonmetal typically, there might be exceptions to the rule, but pretty much it's metal, nonmetal. Now, covalent between two nonmetals, again, could be an exception to the rule, but always between two anions. So what we'll take a look at is we'll do a couple examples and I'll walk through them. So we have Fe2O3. Okay, Fe is iron, which is definitely a metal. Oxygen, definitely non-metal. So this is going to be ionic. And I'm just going to represent it for an I. Now, dinitrogen pentoxide. So nitrogen is my first element. Oxygen is my second element. So therefore, these are both anions and they're both nonmetals. So it's definitely covalent. Magnesium sulfate, MgS. Magnesium is a cation. Sulfur is an anion. Magnesium is definitely a metal. Sulfur, nonmetal. That's ionic. Carbon tetrahydride. Carbon is a nonmetal. And hydrogen, a nonmetal. Now, I know these can go both ways, so it gets a little tricky, but we go back to two nonmetals, which makes it covalent. Sulfur trioxide, sulfur and oxygen actually are in the same family, group 16, and they are both nonmetals and they're covalent. Potassium oxide, potassium is number 19, and that's a metal, and oxygen is a nonmetal, so that makes this ionic. H2O, which is water, hydrogen's a nonmetal, oxygen's a nonmetal, so that is covalent. And nitrogen oxide, we have a nonmetal in nitrogen, a nonmetal in oxygen, once again, covalent. So being able to not only identify through formulas, but also names will be important for your assessment on this objective.